let's take a look at graphing polynomial functions. So our goal today for these notes is to be able to graph the general shape of a polynomial given some information. We're not going to do anything exact here, but we're going to get the basic shape and determine the end behavior of a polynomial when it's graphed. So first of all, some background information here. When you have a polynomial, the degree is the degree of the leading term when you put it in standard form. So it's the one term with the highest exponent. And when you have an even degree polynomial like x squared or x to the fourth, the arrows point, the ends of each end of the polynomial graph, the lines, the arrows, point in the same direction. And when you have an odd degree polynomial, they point in opposite directions. Okay, so let's take a look at some examples of each. So when you have a positive leading coefficient for an even degree polynomial, the arrows point up. And if you have a negative leading coefficient, they point down. For example, if we have an x squared parabola like we've seen before, if the leading coefficient is positive, it'll look something like that. If it's negative, they'll look something like this. That would be a higher degree, possibly x to the fourth. Either way, you see the arrows point down. And the thing about an even degree polynomial is, yes, they can have no solution. For example, if I have it like this, this doesn't touch the x-axis. And remember, the solutions to a polynomial graph are the zeros, the x-intercepts. So yes, these even degree polynomials can have no solution if they don't touch the x-axis. For odd degree polynomials, if we have a positive leading coefficient, the graph goes up to the right. Think of a positive slope for like a y equals mx plus b linear function. So it might be something like this, up to the right. And for a negative leading coefficient, the graph goes down to the right. So our arrow starts up this way and maybe down like this. And these cannot have no solution because since the lines go opposite directions, they'll always cross the x-axis at least one time. So there will always be at least one zero in an odd degree polynomial. Okay, so we're going to use some information here to graph a possible draw a possible graph for these polynomial functions. So the first one here says x to the third minus x squared minus 6x, and the zeros are negative 2, 0, 3. So let's go ahead and start by putting the zeros on the graph. We have negative 2, we have 0, and we have 3. So we know the graph goes through these 3 points. We know that it has a positive leading coefficient, positive 1, and we know the degree is odd. It's a 3. So we have to have our lines going in opposite directions, and because it's positive, we'll overall go up to the right. So our graph should look something like this. Start at the bottom left and go up through the first point, down through the second, and back up through the third. Something like that. Now the actual graph of this polynomial, these may be higher or lower. Can't say for sure based on what we're doing today. We're just going to get the general picture of these graphs. Okay, example B, for a degree 4 polynomial, so it's even, they point the same direction. Our leading coefficient is negative, so we'll have something like this, right? Pointing down, and it's an even polynomial. Now our zeros are negative 2, 1, 2, and 3. So I know because it is negative, I'm going to be starting in the bottom left and ending in the bottom right. So somewhere down here, go through the first point, down through the second, back up through the third, and down through the fourth. Like that. Okay, example C, we have x squared plus 6x plus 5 with zeros, -5 and -1. So let's put those on the graph, -5 and -1. It's an even degree, so we'll have our arrows pointing the same way, and because it's a positive leading coefficient, they'll be pointing up. So down through the first one and up through the next one. So essentially you want to hit all the zeros while still maintaining that end behavior, pointing the same direction for even, opposite direction for odd, pointing the correct direction for positive leading coefficient or versus negative leading coefficient. Let's do a few more here. For example, D, we have a degree 1 polynomial. This is a linear equation for degree 1. The leading coefficient is 1, the zeros are 2 right here. That's just a straight line. And actually, we could potentially graph this. We know if the leading coefficient is 1, that's the slope, right? So we know what the slope is. And if it goes through 2, we know it looks exactly like this. But as long as you get it through that one point, pointing the correct directions, you're okay. Now, degree 7 polynomial, the leading coefficient is negative. So we have an odd degree, negative leading coefficient. We're going down to the right. Our zeros are -4. -3/2 is -1.5 right here. 0 and 1. Now this is a degree 7, so we could have up to 7 zeros. We only have 4. And so this is potentially going to be a little tricky. We'll have to be careful. We're going down to the right. So we know we're going to go through this first one, back up through this second one. Now if I go through and then back up like this, I'm going to be pointing the same direction. I can't have that. I need to be pointing opposite directions. So we're going to go down, up, down, and then we're going to touch that one but not go through it. I'll try to do that a little neater. Down through the first one, up, down, and then we're going to touch the x-axis here but not go through it, and back down. So if your line or your graph touches the x-axis but doesn't go through it, that is still a 0. And so some of these were repeated. We don't know. We don't know the actual polynomial. We don't know the actual graph, but we do know that it goes through those points and has an odd degree, so it's going opposite directions, and it's going down to the right because of the negative leading coefficient. Let's try example F. We have an even degree polynomial with a negative leading coefficient, and we have no solution. So we're pointing down, going the same direction, but not touching the x-axis. So it just looks something like this. We can also know that it goes through -8 on the y-axis, but for now, we're just going to, something like that. We know, we're just getting a general picture, so we know it's going to look a little bit like that somewhere. If you want to try to be more accurate, you could always try to put it on a number like 2, and then maybe your graph was counting by 4s or something like that. But it doesn't matter. Just make sure it's pointing the right direction. We're just getting the end behavior here, so that's what we want to see. So for no solution, we're not touching the x-axis at all. Just both arrows pointing down because it's negative and even, and not touching the x-axis. So that is a quick way to get a general picture of a polynomial graph. Nothing exact here except for the zeros and the direction that the lines or the arrows are pointing.